Greetings to everyone. Welcome to another presentation on the topic electricity, where I'm going to be taking you through May-June 2024 paper 1, question number 8. This is the electricity question that was written in June. It's a national paper for the supplementary. It's actually supplementary paper. Right, it was a bit challenging question because it had so many unknown values. But I hope after this presentation, you are going to have a bit of light and a better understanding of how we deal with such a question. Sit back and relax. All right, so the question has got a cell or a battery. In fact, it's two cells that are making up a battery. Internal resistance is given. Voltage or EMF of the battery is also given. Right. Here we are not given anything. Resistance of R2 here is not given. In fact, it's RZ. Yes, it's RZ is not given. Resistance of RY is not given. Resistance of Rx is not given. But we've got some information that is given here where the examiner is telling us that resistance of Ry, this is our Ry, is twice the resistance of Rx. So it's more of a ratio that we are being given here, the ratio of the resistance of Ry to the resistance of Rx. I'm going to just use a different color to indicate that ratio. Resistance of Ry is twice. That's 2 twice the resistance of Rx. Here it's 1. So the ratio of the resistance is 1:2. It is a very important ratio that we are going to use for some calculations. Okay, we are also told that when both switches are closed, so we have two switches here, switch S1 and switch S2. When they are both closed, the reading on the ammeter is 5.5 amperes. So it's 5.5 amperes here. That is the reading. Okay, right. So when both switches are closed, let us trace the flow of current. You have to know which resistors are having current flowing through them. Right. So current, you must know that current flows from the positive terminal. So my arrow is going to start from here. When current gets to this point, it is going to be divided. Some will flow through resistor Ry and some will flow through resistor Rx. Nothing will flow through the voltmeter because a voltmeter has got very high resistance. So as a result of the very high resistance, no current will flow through it. Right? Then it will flow down here. Current from Rx will combine with current from Ry at this point. Right, when current gets to this point, all the current is going to flow through switch S1. No current will flow through resistor Rz. The way current is divided, when it has an option, let's say that two paths, one with high resistance and another path with low resistance. More current will flow through a path with the least resistance, and less current will flow through a path with high resistance. Now we have a situation here whereby this path has resistance, and this path with the switch does not have resistance at all. So all the current will flow through a path without resistance. Okay, so nothing is going to flow through resistor Rz. So it's as good as Rz is not connected to this circuit. So basically, this circuit will be just a circuit with only two resistors connected in parallel when both switches are closed. Then from this point, current will flow through the ammeter. From the ammeter, it goes back to the battery. So this is how current is going to flow when both switches are closed. Okay, right. So that's the circuit diagram we are dealing with when both switches are closed, because we are also going to look at a situation whereby one is open and another one is closed. So for now, let us deal with when both switches are closed. Okay, right. So like I always say, the first thing to do, or the point of departure when analyzing, look for a part that is two quantities given. Then you look for the third quantity. Right, let's check here. Where do we have two quantities given? Right, we are given the amount of current flowing in the circuit. That is the amount of current flowing through the internal resistance. So with the amount of current, let me write it here, 5.5 amperes. So with the amount of current flowing and internal resistance, we can actually calculate our V internal. So I'm going to start by calculating V internal. Right, our EMF, let me write it first there. EMF is equal to 12 as given in the diagram. Then our V internal formula is V internal equals I times small letter r for small internal resistance. So that will be 0.2 multiplied by, okay, let me just start with the current to avoid confusion. That will be current of 5.5 multiplied by 0.2. That will simplify to 5.5 times 0.2. 1.1 volts. That is the internal voltage, the voltage that is being used inside the battery by the internal resistor or the internal resistance. Okay, now that we have our EMF, we also have our V internal. We can calculate the V external using the formula EMF equals V external plus V internal. Okay, we have our EMF is 12 equals V external plus 1.1. So our V external will now be right, it will be 10.9 volts. Right, so our V external being 10 volts, it is just the voltage being used by these two resistors in parallel, because these are the only two resistors that are involved in the external circuit. So voltage, let me indicate the voltage here is 10.9 volts. Okay, so we now have the voltage across the parallel. Right. Now we can move on to making use of the ratio that we are given. The ratio of 1:2 to calculate the amount of current flowing through Rx and the amount of current flowing through Ry. How do we use that ratio? Right, the ratio is Rx is to Ry, a ratio of 1:2. What it simply means here is Ry is higher resistance as compared to Rx, or the resistance of Ry is double that of Rx, like what you are told here. Okay, so to get the amount of current flowing through Rx, the one with low resistance, we use the higher ratio or the bigger ratio. So it's going to be Rx, meaning current flowing through X. So it's a bit tricky You are calculating the current flowing through Rx, but you have to use the bigger ratio here. So it will be 2 divided by the total ratio 1 plus 2, which is 3. Okay, so 2 divided by the total, which is 3, multiplied by this current, because we want to determine how is this 5.5 amperes going to be split when it gets to this point. Okay, so we multiply the 2 over 3 by 5.5, which will give us 2 over 3 multiply by 5.5. 3.667 amperes. That is the amount of current flowing through Rx. Right, to get the amount of current flowing through Ry, that will be Ry, we use the smaller ratio because the resistance is high, so the amount of current flowing will be lower. So we are going to say 1 divided by 3 multiplied by the 5.5. We could have also calculated the amount of current flowing through Ry by just subtracting the 3.667 from 5.5. Okay, so 1 over 3, that is a third of 5.5. 5.5. It gives us 1.833 amperes. If you add these two amounts, they will give you 5.5. So check here, Ry with a higher resistance, it has less amount of current flowing through it. Rx with lower resistance, it has higher amount of current flowing through it, which makes sense because current is inversely proportional to resistance. The higher the resistance, the lower the amount of current flowing. The lower the resistance, the higher the amount of current flowing. So we now have the amount of current flowing through Rx and Ry. We also have the voltage across all the two resistors. So we can now calculate the resistances of Rx and Ry. So I'll move on to calculating Rx. Resistance is equal to voltage over current. Voltage being the 10.9 divided by Rx, current flowing through Rx, 3.667 equals, right, that will be 10.9 divided by 3.667. I'm getting here 2.972 ohms. Okay, that is the resistance of resistor Rx. Then resistance for resistor Ry, that will be Ry is equal to voltage over current. Voltage is the same voltage because the two resistors are connected in parallel. 10.9 divided by resistance for resistor Ry, 1.833. That simplifies to 10.9 divided by 1.833, 5.947. Okay, so that is our resistances for the two resistors Rx and Ry. Okay. Now you can see that already we have answered this question. Calculate the resistance of Ry. We now have it. There's a question here asking us to calculate the power dissipated by Rx. Right, power, since I have obtained the resistance of Ry, of Rx, and I know the current flowing through, I can actually make use of the formula power is equal to I squared R. So the current flowing through Rx, we say it's 3.667. We square it, multiply by resistance of Rx. Resistance of Rx is there as 2.972. Let me use my calculator to simplify. 3.667 squared multiply by 2.972. Right, simplifying to 39.96. That will be in watts. Watts, that's the SI unit for power. Okay, right, so I'm done with when both switches are closed. Right, we now move on to when both switches are opened. When both switches are opened. Now let me open both switches. Right, this switch opens as well as this switch opens. Right. So when both switches are open, the way current flows will change. It is not going to flow the way it was flowing when both switches were closed. So we no longer have current flowing through this path. So I'm going to erase this to show that there is no current flowing through this path. Right, again here, no current will flow through this open switch.